Welcome to a new test and teardown video. This time it's another Radiometer product. A regulated power supply type SE21. This design is from 1963. We've got multiple outputs and it's high voltage. Look at that. 0 to 500 volts, 200 milliamps. So that is quite a lot. And we got two independent AC filaments, 5 amps each. And they even say here how you can strap those two together to get 12.6. So that is very convenient. And we got a variable bias supply, only 1 milliamps. 0 to 50 volts, and then there's another fixed 150 volts, 25 milliamps over here. So the way that this is made is actually a little bit simple, because I looked a little bit at the block schematic and in the schematic. So I know now that this bias control is this output is just a pot meter, and it goes a little bit tight. So it's just a pot meter on that fixed 150 volts. Of course, a series resistor, so it's limited to only 50. There's only 1 meter here, so there's a switch for the meter, so you can go super fine on the bias control, 5, 20 and 50. And you can also measure the output current of your high voltage, 500, 250 volts, full range here for the high voltage output. I think this is only a meter range, so that means if you're in 500, you should of course be careful not to switch this down to 50, obviously. So I think this is really why it is made like this, so it's safe to go from current back and forward like that, and then you can go down to the finer ranges. So that is really smart what they've done here. So this one was super tight, and this one is super loose, also like that. This one is a multi-turn, and of course this is mains supply and the high voltage on off. This unit is just so fantastic when it comes to specifications. I mean, this is some impressive data. Maybe I will put a link in the description where you can go and download the entire manual. I mean, seriously, you need to read the specification sheets. It is just amazing. Even today, when it comes to ripple regulation and all that kind of stuff, imagine this is only done by tubes, and it is that fantastic. I heard this one should work, so let's not delay this any further. Let's power it up. Yeah, so let's power it up. There'll be mains input and oh dear. Hello. Okay, that was disappointing. Sorry about that. There's a problem. Well, I think I found a problem, or evidence of another potential problem. Well, this fuse is not just blown, but it is exploded. Look at that. It is super exploded. That is not a good sign, so I think we need to open and have a look. Let's have a little look inside this unit. It is just amazingly compact designed. Wow, look at that. And there's a massive transformer down here. But of course this explains the about 15 kilos, this one. It is really heavy. It consists of two PCBs, more or less the same size of the whole unit. And I think we can maybe take out the two screws like this and maybe bend out or flip out yeah, maybe that is how it's done. It is really beautiful layout work. Oh, I love it. So that's a ground star point of big importance. Here's the text on the PCB. There's actually quite a lot of really cool design features of this unit, so I can't wait to show you all the cool details. But yeah, there's a lot of dirt and dust. Oy, oy, oy. I better go and get the compressed air, huh? But look how compact it is. You need to... Oh, you can't even stick in a... Look at that. You can't even stick your hands in here and do anything. Now this pot meter is defect. I might as well just show you how they work. Because it's a multi-turn, obviously. So when you dial this, dial, there is this wiper that just goes all the way up and down here. And see, this plastic here, it's made so it follows a track around and around and around. So it's a very long wire wound resistors track, like that. So yes, this just needs a replacement. This is one amazing product. And now we're in the other side here. Got some Zener diodes, a little signal transformer and a rectifier here. And this circuit is actually a very, very special primary regulator using those Zener diodes, and then they put in like a square wave through this transformer, and then it is used to regulate a pre-regulate the high voltage supply, by the way. So I think we're gonna go and have a little look on the schematic so you can see what they're doing here, but this is actually quite special what they're doing here with the pre-regulator. I think I figured out what damaged this pot meter, because it's quite long like that, and it's really, really thick and stiff wires, and they're soldered, as you can see here, a little bit too short to that pot. And the wires down here is actually a little bit in the way. When you move this, you actually create like a pull on this wire when it goes stuck here. I actually did stick my fingers down here and push the wires away. So that means now I can open and close this without causing any further damage to those wires. But they're kind of stuck in here somehow, and I can't really see what is going on. Of course, they're not supposed to be in a position where they get torn by metal touching like that. That is of course not the way it's supposed to be. The pot meter is isolated from the chassis, and the pot meter knob is fully, let me show you guys this. See, it is fully covered in plastic. There is no screws or anything not plastic on the pot meter. The top of the pot meter is also a plastic you screw in here, and this is a solid brass piece that is made to fit on the pot meter shaft. Even two set screws like that, and then you put the knob on here, and there's a little plastic thingy like that goes in this groove. And then this screw secures that. So it's a quite complex, this knob. And the other one is, of course, the same kind of style, but that is a little bit sticky, stiff and all that. So yeah, the fuse was definitely blown, and not just blown, but it completely exploded. So when you see something that is that exploded, I mean, I need to open stuff, you know, do whatever I can of stuff that is visible, and then crank up the voltage real slow. Here's my idea. Since this potmeter is 125 kilo, so it's not that easy to find. As you can see here, 125. So I put in epoxy like that into the groove, and I assembled it real nice. All I have to do is push a little bit like that, and then it goes back together correctly. And when I'm turning it now, it even feels and sounds perfectly fine. So I hope I repaired it. So where is the short here? I put in a new fuse, and I'm testing here with only 14 volts of mains, and look at that, 1.4 amps, and that is 19 watts. And I actually get a little bit of output voltage, and it's of course not responding to anything, right? So what am I doing here with my thermal camera? So I'm looking at the boards, really careful. I'm searching around for anything that could potentially be warm. Diodes, no way. Shorted capacitors, where the heck is the short? That is the transformer. So it appears like this one gets very hot. Transformer is... So we can really see down the windings like that, right? Look at that. Warm and warm. And that is the mains voltage selector, including the fuse. So of course that one is warm. So that is the other PCB. And look, there's a lot of shiny components. So that means when I hold my hand like this, it is very easy for me to create a reflection from my hand. See all the red spots up here? That's because the edge of those components that is really nice and shiny. So my hand is creating that image. So that is what you need to be, aware of when you're playing around with thermal cameras. And see the rectifier diodes there, really nice and shiny. And that is, see, if I change my angle, it is not really there, right? And by the way, that is the mains on-off switch. Look at that one. So current definitely goes through that one. And you can even see the wires that carries the 1.4 amps. Look at that, the wires goes that way. Isn't that amazing? So I don't know, I'm a little bit stuck at the moment, I must say. This is really annoying about this weird short here. So now my new idea is to try and disconnect some of the secondary wires from the transformer. We've got quite a lot of secondary, but they're really good with all the color codes. And it also says here on the transformer what windings they're what and what they're doing. So what I can do is just disconnect one here and one there and so on. And this way we don't pull any current out of the transformer, right? It's been driving me absolutely nuts about this short. So where the heck is that short? So here's what I've done. That will be all the high voltage rectifiers and whatnot, right? And here's the yellow wire that goes to the high voltage. I removed only that yellow wire, and you know what? Now the short is gone. Ha ha. So let's look at the schematic. The yellow wire we cut is that one. So we got two capacitors that could be shorted, but could also be shorted diodes. So that is what we need to investigate. That was lucky and that was easy. So that is the high voltage rectifier diodes. They all beep okay. And the 1K and C11 in parallel, that measures 0 ohms. But C10 also measures 0 ohms. So that is a little bit spooky. But so far I'm going to remove C11 and then let's take it from there. So both C11 and C10, they are shorted. And look at that goobity goop. I guess that is coming from this one somehow. I really can't see it. Well, I don't know. But that is definitely capacitor goop. It's all wet there, and that was the little dumb C11. That is shorted too. How annoying. But anyway, that was easy to find. So I put in some polycarbonate. I think they're there. Or film capacitors at least. They're definitely much better for the job. They handle high ripple currents and all that kind of stuff. So that is a lot better compared to all that old crap here. So I think I'm actually ready to power this up now and see what happens. So I feel I am ready to do a new power up. I can't remember if I told you guys about this high voltage pot. I really did all I could to try and save it and mount it all right and all that. But what I didn't see is, look at the shaft, how bent it is. So when I turn this around, it goes hard and then it goes soft every half turn. So the shaft is just totally bent, and that is of course why it was broken. So somebody was carrying around with this and hammered it into something. So yeah, and it is 125K, so that is a little bit annoying. I put in 100K, all plastic, so I feel this is going to be safe. And I cranked it all the way down, so I don't expect this to go all the way to 0 now. So there's probably something that is going on here. So on, and that is mains voltage is in, and we will get output. I don't actually understand why we get output when everything is cold, and I got only 15 volts of AC input. So that means this regulator is probably going to hammer out a lot of voltage when you boot this up. That is a little bit weird. So let's try and crank up the voltage here until we see some lights in the lamps.
Sorry, I'm having trouble connecting to the internet. It looks like an issue with the router and echo device, so try restarting them.
Great.
Unplug both of them, then plug the router back in. Wait for the
Alexa, how about you shut up?
router is back on and connected to the internet.
What is it with this
Plug the
stupid
echo
thing?
device.
La 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 blah 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 blah. Okay, so we got light in the lamps. Let me turn this off. So 47 volts of output. I am now at 150 volts of AC. Let's just crank it up. 44. I hear something. What is that? I don't like that sound. You hear this? The tick, tick, tick. What the heck is that? That can't be good. Oh. There's a weird sound. But look what I got here. I am in 500 volts full range, right? 250 on that meter. 250 on that meter. So, man, it works. Let me see how much it can do. We'll see. 428. And that is, of course, because I need some more resistance. But that means it's, of course, going to 0. Look at that. I think we got a winner. What luck is that? Yeah. Let me turn off, crank down the light here. Maybe I can turn off some more light for you. It's probably gonna look really beautiful in here. But I don't like that sound. Can you hear it? What is it saying? Tick, tick, tick. I don't know. I better go and get my thermal camera here. Because I don't like the tickety tick sound here. So hang on, I'll be back. Ooh, it is scary to go around here and look for thermal issues. And there's definitely something that goes clickety clickety click. I just turned it off now. But that resistor there gets a little bit too hot if you ask me. But I cannot figure out. In this area there's something that goes click click click. So that is a little bit weird. Also see a little bit of funny stuff around the resistors and stuff like that here that probably need a little bit more cleaning. I don't hear anything over here, and I do see everything is just warm. It's a minute ago since I turned it off, and I see all those resistors down there and all that kind of stuff that gets nice and warm. But over here in this area it's definitely within what I can live with. Now I'm just playing around with the different features here. This is my 0 to 50 volts. And look at that. That works perfectly fine as well. And then there's a fixed 150, and that one works too. And I did not adjust anything. It's actually quite amazing to see it that accurate. So this is the very warm one that I've been poking around with. That gets warm, and it says this click 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 sound, because it gets very, very warm. So, and we got 164 volts RMS over R1. And if we look at the schematic, we see those two Zener diodes. We got about 8 volt on those. And that is actually the voltage reference, the pre-regulation system that goes through the this transformer, and the voltage on the other side of that transformer is used to trigger like a switch mode pre-regulation kind of system with this tube here. And so that tube actually works just like a triac will do in a conventional circuit. So when you trigger this tube, it will keep conducting and charging the capacitors, and it will keep conducting until there is no current going through it anymore, and then it will stop conduct until the next rising edge, and then you need to trigger it. So this is how the pre-regulation works. And the cool thing about this is you have very little voltage over the series regulator tube, and the series regulator tube is that one over here. And that means you can draw. This is all the regulation and the voltage references and all that kind of stuff, by the way. But the series regulator tube, we only need one tiny tube like this. And it's not even getting, warm or anything. So that is genius of them to figure this out. I got other tube regulated power supplies, and we need a bunch of these to give you even less power. So yeah, a pre-regulated switch mode kind of system. That is nice. So now this wonderful old unit is up and running again. And this was my test pot meter that is 100 kilo ohms. And the original pot meter here is 125 kilo ohms. And the circuit around the voltage setting and all that kind of stuff, well, you really need the 0 to 125k to do a 0 to 500 volts. So I can't find a pot meter like that value. So I repaired the old one with epoxy, and all that was fine, but the shaft was bent, so I couldn't really turn it around. So what I did is I found out exactly where it was bent, and then I straightened out the shaft. So look at that. Now it is going perfectly fine again. I gave it a tiny little drop of oil as well, and now it is as good as new. So now I'm gonna install this and see if it works. So I had to cut away all the nice binded, tidied up cables here, because the cables, they're really stiff the way they are, already. And if you tie all these cables up, it gets super stiff. You can't move them around like this. And then, like you can see here on the white cable, you're kind of eating away some of the isolation material when it's touched by anything here. But now it can freely move away. And also the cables for the pot meters are way too thick and stiff, and also I had to loosen all this to get more cable, but they're so stiff that I really don't want to break the pot meter again, so I made some really nice and flexible cables here. And with the pot meter in here and the shaft is straightened, yes, I think if you look here you can maybe see that it's not perfect, but I think it's actually the knob that I put on here, but it's nice, isn't it? Yeah. By the way, this piece of isolation material here also had a crack in it, so yeah, it received a little bit of pain. So after everything is fixed and assembled, let's try and power this up and see what happens. See, we actually do get some voltage out. I have this low, and this is while it's warming up. We will get a little bit of output, and then it goes to 0. It actually goes below 0, and then it is nice and stable like this. And then you enable the output. That is a normal power up sequence. And now we can crank up the voltage. So the maximum is 495. Well, I just powered it up like that, and it is of course ice cold. So if we wait a little bit, it's probably gonna go to 500, as you see here. What we can do is we could actually load it as well now. Well, let's crank this down. Let's give it 10 watts is nothing, right? Ooh. So that is 50 watts, 100 milliamps. That is 50% of its capability. So 50 watts here is, I don't know if you can see that. Oh, let's have a look. input power is 137 watts. I really would like to see how this performs at maximum potential. Oh, did you see that? We went into current limit. Okay, let's go back to 100 milliamps. So that is 100 milliamps. Okay, let's go back and see the amp meter. Amp meter is also correct. All right, so there is a current limit that is not working as, let's try again, see how it is. 150. Ooh, let's go back. Okay, so 150 milliamps is what I can do. Let's see here. Yes, 150 milliamps. And of course, 75 watts is nothing for this load, so no big deal. But yeah, I think I will call it a day, and thank you very much for watching. I hope you enjoyed the video, and please come again tomorrow. Bye bye.